Yeah, feel free to interrupt me at any time and ask me a question about the syntax or just anything I'm talking about. Yeah, so hey guys, you might remember last time I talked about Himesama, which is a library I've been working on. Himesama is basically a replacement for React, or it's kind of an iteration on React. It was really meant to address the same problem that Redux is addressing, in that you have all the state stored in different components. How do we solve that? We put state in a separate place outside of the component tree. I did the same kind of thing, except a different way. I'll go through it really fast so I can talk about the new stuff I've developed. But you can see here on the left, I've got basically just my application. Just like React, I create a class, and it has a property called render, and that shows how it's rendered. One significant difference is I do this thing called a init state, where I init the state that will be the global state for the entire application, and when I want to reference that, I reference it like this dot state, just like plain old React. And then when I do set state, it sets the state like that. The rendering works a different way though. I give components a property called needs, like you can see up here. So when those parts of state change, it knows to re-render these components. That's how it works, and it's been working pretty good. I built Himesama out, and then I started using it, and I made like 6 or 7 different applications with it, and it was going great. And then I came to kind of my ultimate application, which is this spreadsheet software. Oh, this is totally unreadable. Anyway, so this is my spreadsheet software. I have cells. If I want to add something, I just click a cell, and it puts that content there. If I want to make a new sheet, I can hit new, get a new sheet, put content over here. I have 2 sheets, so if I go back to this one, you can see that it'll edit it on the left or right one if they're both on the same one. Anyway, this is an application I made kind of for myself, but since I was working on a rendering library, it's also a way to test my new rendering library. I got to working on this, and I filled it with I got to the part of the development of this application where I needed to open up a lot of data. Actually, that's not true. I just want to open up a lot of data and just see if it would work in my spreadsheet software. So I opened up some Danish immigration data, and I just filled the whole thing up, and it started to lag a lot because there's a lot of data. It filled up every cell, and then when I would go into type in the cells, and it would slow down. And I'm like, oh no, now I have to actually worry about optimization. I have to actually worry about rendering and how to make it work faster. Just to be clear, that I had, when it started slowing down, it was 11 by 40 about, so it was about 800 HTML components that it was updating each one automatically, or it's updating. It had to check 800 different HTML elements and then destroy them and then re-render them. So I guess I'll talk about how it originally was re-rendering. If you have HTML, right, it's kind of a tree structure where for any with HTML, if you're doing it right, you only have one body element, right? And if you're using React, every component just starts with one HTML component. So you have this feature of the tree where it all starts at one component. Everything has one and only one parent element, HTML element. There's another tree. So there's the HTML tree, but when you're doing React, there's another tree which is the tree of React components, because all React components start with one HTML component. So if you want to diagram your React app, you could diagram it in terms of the HTML or the components, because the components always go back to one HTML component, which will be where it plugs into the HTML component of the parent component. So you guys can kind of see how they go from one to the other. So the way I had Himesama re-rendering was that it would if the component had a need, it would remove the HTML of that component. It would find it with the address. You know how, have you ever looked at the HTML of React? It has React. Every HTML element has an attribute called React ID, and then the value of that is just like, it's an address. It has just numbers. I did the same thing. So it would find that HTML component with that address, just remove it, blow it away, and then re-render that part and just stick it in there. And that's how React originally worked too, way back in the olden times of 2013. It's changed a lot since then. That was the funny thing about researching React, is there's so many contradictory answers because it changed every month. People don't take their blog posts down. They just kind of leave that up for it. Anyway, so that was how I had it working, and it didn't really work that well once you have 800 HTML elements to re-render. So I had to find a way to make it more efficient. And when I first started thinking about it, Jeff was really nice, and he showed me a library called Diff HTML. And what Diff HTML does is you say, you give it an HTML component, and then you give it basically a string of HTML, and it'll re-render the actual HTML on your page with what was in the string. It'll do that efficiently. And so I got to talking to those guys a little bit. I tried to study their code, but is a little difficult. But it really got me started with optimizing the process. The way I got, so a little bit about how React and therefore how Himesama works is I have what's called a virtual DOM. And a virtual DOM is a tree of JavaScript objects. And the tree of JavaScript objects has a correspondence to the tree of HTML objects. Every JavaScript object in the virtual DOM has a parent, it has children, it has attributes. And since every HTML component has a parent, children, attributes, you can kind of correspond them. I'm sorry, I shouldn't be saying parent, I should be saying type, like div or paragraph. So every JavaScript object has type, it has attributes. The attributes is JavaScript objects. And it has children which point to other JavaScript objects which are the same. They have a type, attributes, and children. So the way I had Himesama working was it would just take the virtual DOM, render it, and then stick it in the HTML. Right? I needed a better way of doing that. And the first way I got to thinking of that is I diffed it against the HTML. So I wouldn't just re-render it and then stick it in. I would actually compare it and see if it needed to get changed. And a little bit about what diffing is, because when I first jumped into optimizing diffing and merging and rendering is a little confusing, because I thought diffing, if someone just said that to me, I would think it's going to show me the differences. Like if you diff text, it just highlights the differences. But with like Diff HTML, that great repository that Jeff showed me, they used the word diff to refer to the whole process of actually swapping out the HTML. So it's a little confusing just getting started. I really broke my project down into diffing, merging, and then rendering. So merging is where you actually you know what the changes are, and so then you have to work. Given those changes, how do you change the HTML to align with the new virtual DOM? So my first process was I was diffing the HTML against the virtual DOM, and that worked, and it was speedy, and everything was good immediately. It didn't slow down when it needed to render 800 HTML components. I'd open up the console and you could see the HTML. When I would do a change before, everything would light up because everything was changing. But now it's just the attribute of what I wanted was changing. By the way, just as an aside, let me find diff, my diff file. So the way diff is really simple. It's down here. It's just you give it A and B, which are both virtual DOM components. It converts those into a string, which is actually even simpler than the HTML. It's not a string representation of an HTML object. It's literally just div, and then it's the attribute value, attribute value, attribute value, and that's all it needs. And if you think about it, if any of those things are going to be different, then the string has to be different. So that you don't even need to put full HTML. I was even thinking a little bit. Maybe I don't even need spaces, but I'm pretty sure you need spaces. But
is it just a JSON, like JSON to stringify, or?
No, I made it myself. That's what this function that.
Would JSON stringify work though?
It probably would. Yeah, I'm sure it would. Maybe I did a little bit too much coding. Maybe I could have just done JSON.
Might be something to try. Yeah.
For a little bit, when I was diffing between the HTML and the virtual DOM, I had to have a function called HTML to string and then virtual DOM to string, and I had to make sure that they had things that looked the same. Otherwise, it would be diffing mistakenly. And all the diffing algorithm does is it just returns is string the other string, and is really speedy. Anyway, I ran into a problem with that with just diffing between the virtual DOM and the HTML, which is that if I needed to change the HTML, I would if I needed to update the HTML, I would blow away the virtual DOM, right? I would say I'm going to render this part of it, render a new part of it, and replace it. So I have the old the old virtual DOM components, which would hopefully get garbage collected, right? Because they're no longer attached to the tree. But the HTML didn't change, so the event listeners on this HTML component were still attached to what would have been garbage collected. So all of a sudden, if I needed to render anything, all of a sudden it couldn't actually. The event listeners, which are crucial, wouldn't function anymore. So that was kind of a disappointment. By the way, any questions so far? I know I'm shooting through this.
Didn't React solve that problem by basically just attaching a big event handler onto the thing that you render into, like the parent React rendered to? You just attach like a big event handler on there, and it just resolves the events internally.
Yeah, I'm sure they do something like that, because React's so massive in file size. There has to be something in there, something like that. I was thinking about that, like having a manager of event listeners, and then just having the HTML component would point to the internal collection of event listeners, and then you would just update what the collection is. But I didn't want to do all that coding. That sounded like a mess. Yeah.
I'm curious. You're mentioning some of the DOM to strings. So when you're diffing it, are you the actual comparison? Is that taking place at a string level or at an object level?
String.
Okay.
Oh yeah, I did. I wanted to get a sense of how to optimize this, but to get a sense of how to optimize it, I had to get a sense of how long it was taking, how long these HTML rendering processes were taking. And I found that to create a new HTML element, actually, it takes a long time relatively to everything else. It takes about 10 times as long as just updating an attribute. So I realized. Whenever you're optimizing anything, it's like you want to figure out some elegance to it, and then you know the math, and then you can just sort of implement that, and then it works great. But what I realized pretty quickly was that, well, everything's more optimal than the least optimal way to do it. So it's really not going to take much to get something that works. If I have to remake every HTML component, and that's the longest or the most costly known process, then anything will make it better. Even if I'm going to resort to always re-rendering, if I only have to re-render one element out of 800, then it's 800 times faster, right? So that was a realization I came to. Was there another question? Or yeah, Sam?
Throughout the process, where did you find, I guess this pops up in React too, where did you find was the best way, and how do you handle like styling changes and their rendering to the virtual DOM?
So I use a lot of classes. Let's see, do I have an example of actually using classes? Yeah, so here's my cell div. I refer to the class name. Here I have to do some funny stuff with the class name to swap whether it's going to be filled or not, because when it's filled, I like them to light up, so it actually puts a different class name there. But I sometimes I'll do style. You can see how similar it is to React. If I want like margin left, I can do that. I do that. I do all this for convenience, but my understanding is that class names work faster. Anyway, I guess I'll go back to talking about the actual rendering. So when I realized that I couldn't just diff between HTML and the virtual DOM, my solution was I was going to diff between two virtual DOMs, and then when I found a difference between the two, I would fix the primary virtual DOM, and then I would fix the HTML in the same way. So it really wasn't associating virtual DOM with HTML anymore. It's more like I had two parallel structures that are always identical, and when there's a relationship between the two virtual DOMs, I need a corresponding relationship to happen to the HTML. I need that to update the same way that the virtual DOMs can update. So I started talking in terms of let me bring up merge. Models and drafts. So my model was the primary virtual DOM, and whenever I had to update, I made something called a draft, and then it compared them, and then it made the changes. This worked pretty well. It's not really. It's not my favorite code. I realize that they're really. There are three possibilities that can happen when you need to update the HTMLs. One, you're adding an element that wasn't there before, so that's simple. Just render it and then stick it at the end of the child array. There could be something in the HTML that's no longer in the model, so then you need to remove it. Or there's something there and you have something different and you need to just either replace it or give it the properties that it needs. But it got more complicated than that, because when your HTML is really not that pleasant, and it might not be an HTML component what you're in there. Sometimes you put strings in React. Sometimes you just have text underneath in the HTML tag, and it's not really clear what the string in your JavaScript is going to show, how it should be in the HTML, because you could just put a string inside of an HTML component, and then you have then it's like a child, right? It's part of the inner HTML. But you could also you would do that by appending it, creating a text node and then appending it to the HTML. You could also do it a different way, which is that you refer to the HTML component and then you just change its text content, and then it's part of the outer HTML. But as far as I can tell, these are the same thing. It's just two different ways to do it, and it's really messy trying to decide which way. So I'm only gonna do one way. I don't want to worry about two things. That's a lot more than I need. So I just committed myself to one way or the other. But anyway, so that I talked about those three possibilities. One of them, there's four combinations of how you could be changing text to text, you could be changing a node to text, you could be changing text to node, or just text to text. So I had to have conditions on each of those, and that's why I have all these really ugly if statements.
You kind of have to think of text, though, inside an HTML element as being like a tagless element, because you can actually have multiple text tagless elements inside it. Like, for example, if you had a div, you can have a piece of text, and then right after that text, another div, but on closing that div, you have more text, right? And then close that parent div. So now you have like two text elements with a div in between them.
Yeah.
Right.
Yeah, I really wish they invented it differently.
Yeah. Well.
It's a node list, right? So you have node type, and you have to order through the nodes, not as an array, but like an array-like object.
Yeah.
So that's also a way to you can reduce and filter off of your output.
The text stuff also kind of threw a wrench in my code, because part of how I manage the components, the virtual DOM components, is all of them have a property of parent and children. So if my code has its hands on a component and it needs to reference the parent because it needs to change the child in that parent in the HTML, it can just do model.parent. Doesn't need to do anything difficult. But strings don't have that property. Strings don't have the property of parent. They're not objects. So I created an object called, I invented a virtual DOM component that's a component just like everything else called Himesama text, and it just checks if that's the type. Also, components are a type. They're type custom because they need to be handled differently. But yeah, so then I have my render function in here, and it just handles those 6 possible cases. Yeah, and it works. It works as of today. I thought it worked last week, but then I kept using it, and it turns out it doesn't work. Yeah. Any more
you're
questions?
talking about this loading like a huge amount of data into that program, back in your spreadsheet program. So if you do load up, let's say 50,000, 500,000 rows, does it actually create that in the virtual DOM or that in the actual DOM, or does it only render the section you're viewing?
Yeah, it'll be in the virtual DOM too.
Okay, so it actually loads up all like 500,000 rows in the virtual DOM?
Yeah, in the virtual, it doesn't, there's, let me go to the index file. There is something, so right when you do render, it takes the virtual DOM that you give it, and it just saves it into the whole dependency. So it always has that to reference, but you're updating it, so whenever it needs to re-render, it creates a draft based off the render function of that node, and then it doesn't even really replace the virtual DOM, it just updates it. So it avoids removing an object out of the virtual DOM, and it's apt to just give it the attributes. Actually, yeah, it does that right here. So once we find out that there's a difference between the two nodes. If you're comparing two nodes and there's a difference between them, give the model the attributes and the type, and then go compare the children after that. But the first thing you do is you update all the properties of the model node to have the.
So I guess what I'm asking is, if you have like a 1 megabyte text file you're loading into there, you have a megabyte for the text, that gets parsed into, where's that, the canonical copy, the virtual DOM?
Yeah.
You have one copy there plus the actual HTML DOM, and is that built in its entirety or only the view portion? I'm thinking back to Qt days where you would optimize it, where it would only draw the section that fits in the interface, and you might draw a little below that and pre-buffer that, so when you scroll it's nice and smooth and it gives it a little lead time to build the rest below. But you wouldn't render, like you could have gigabyte text files, you wouldn't render the entire gigabyte, you just render the window of that on which you're viewing.
Yeah, I don't. It doesn't do anything like that. It'll give if you it'll render the whole HTML file. Yeah.
But it's kind of a special case for like a grid or a spreadsheet, right? Like anything scroll kind of thing. But
Yeah, like
if you just were just a normal web page, you wouldn't really want that.
yeah, web pages don't tend to get that big.
Right.
But now that we're kind of rebuilding the entire computer architecture and infrastructure inside the browser for some insane reason, you know, like BBEdit, almost no one uses BBEdit anymore, but one of its special features is you could load a log file from the server, which was like a gigabyte, and it would breeze through that thing. You could just scroll to anything. It would just use, you know, disk seek and seek to that point in the file and just render razor fast. You try to load that up in Atom, it just chokes and dies, and like it's trying to render the whole thing. It's like, don't do that. Like, you don't have that much memory to throw at one single document. And today, your gig log file is tiny. We would generate at Amazon somewhere in the neighborhood of 4 terabytes of log files a day.
You know, you could put that optimization logic in the actual render function. Because, for example, right here, I don't render every cell. I render a slice between 0 and the cutoff.
Okay.
And yeah.
Log files like that seems a little confusing. Why don't you just grab what you wanted out of it and reduce the size? I mean, I guess if most people are doing like streaming-based logs.
If you know what you're looking for already, yes. But if you're just looking for an event, yeah, if you're just kind of trying to get an idea for general structure, I mean, yeah, there are way better tools today. You can look at something like Splunk or Elk Stack, something like that. But there still is a place for looking at large data sets. And so...
Yeah, Adam doesn't like more than...
Yeah.
Anyway, any other questions about whatever? Yeah.
Do you have any tests for this?
No, I'm a fool and I don't test. I really ought to. I mean, so a cool thing about working on this is I went through several iterations, but the actual API or the function names never changed. And so once I had 7 or 8 apps that I was using, I didn't have to rewrite my applications. I just changed out what the library was. And by the way, I think this is only up to like 400 lines of code. It's not that much. It makes it all the more mysterious that React is so massive. Yeah.
What is your project name?
Himesama is Japanese for princess, and so I have I'm not into anime, but some friends of mine are, and so it's kind of it's an anime joke, something I'm not familiar with. But yeah, anything else?
Does it support just basic Redux?
What's that?
Do you support just like the basic form Redux, or do you have like fonts?
Oh yeah, no, yeah, it's not a very complicated version of Redux. Oh, but I'll just mention it real quick. I did because I realized that when Redux has props, right, that trickle down, or that you can put into components from their parent components. I realized that that's actually really useful in some cases. We were desperately needing the universal state, but sometimes you actually need that component level state too. So Himesama has both. I just call the internal state attributes, and I call the global state state. Let's see if I have a component that does that. I know I do. Yeah, so it has everything. It has both of the things that you would want.
You're saying you're passing source state, kind of like Redux, down to the child components. Is that what you're referring to?
Yeah. Yeah. Let me show. Yeah. So right here, right here, I'm passing in these three components into the tracker window. This is the tracker view, so it's the whole. By the way, I'm calling this a tracker. There's reasons for that I won't get into, but the tracker is one of these two views because notice how they're identical on left, right side. So this is the tracker view, and I have these components called tracker sheets and options. I'm passing it in these attributes, and then it has those attributes. But the component itself also has a init attributes. So you could say if take the attributes that I'm telling you to initialize with, and if you inherit any, just add those in, and then you could reference those within the component, just like React. So it's just React with a built-in global state, and yeah, and now it's my tool of choice. Also, it can inherit needs, because sometimes I need to tell a component what it needs to be sensitive to. So for example, I have a left and a right one. If I'm updating the left one, I might not necessarily want that change in the right one. So it's cool because there's kind of like not an emergent behavior in this, but because this is new, I didn't realize that I would have to also invent the technique of using this code. And so I'm learning how to pass stuff around. I realized that what works really well is if you want a parent to tell a child what to be sensitive to in the rendering, you should not pass down the value, but you should pass down the key and tell it to get the value of that key from the universal state. That actually works a lot better. So that's kind of the way they're working. And you only get that opportunity when you have both the universal and component level states. You don't. It's kind of a new thing that I accidentally found. But yeah. Anything else?
Really cool. Good job.
Thank you.
Yeah, very nice.
Yeah, I'll be